Myself, Dr. Jibran Ahmed presents to you Simply Pathology, and today we are back with an important lecture. Now, today's lecture is a very special one. Today we are going to read in details about the hematoxylin and eosin staining. Now, this is very important discussion. Why? Because H&E staining, it is acting as a bread and butter for all the histopathologists, okay? And this is the bare minimum stain. This is going to be asked to all students, okay? So all the students in the practical exams, they should know hematoxylin and eosin staining in details. You will be given a particular slide and you will be asked to stain and perform the steps of staining. So please stay tuned till the end of the lecture, because this is a very important topic and you might not like to lose any important point. So let us begin today's topic of discussion. So what is it that we are going to discuss today? We will see the basic and intro of H&E staining, the different types of H&E stains, what is the process of bluing. We will discuss individual dyes in detail. We will discuss counter staining by eosin, routine H&E staining, what are the steps that we follow. Okay, then what are the troubleshooting, or what are the problems that we come across on day-to-day basis, and lastly we will read in details about clearing, mounting and the use of cover slip. So let us begin today's topic of discussion without wasting any more time. So if you see H&E or hematoxylin eosin stain, it is the most commonly used dye in the pathology lab for routine morphological evaluation of the tissue. It is a very good nuclear stain and it gives bluish black coloration. It is obtained from the bark of a tree that is called as Hematoxylum campesianum. Now this is very important MCQ, and the examiners love to ask that it is obtained from what? It is obtained from a bark of a tree. Which tree? Hematoxylum campesianum. And from where? So it is most commonly it is obtained from Mexico, and some of them are also obtained from West Indies. So how is it that you prepare this particular dye? So for example, this is the bark, okay? This is the bark of that particular tree, okay? So you have cut that particular tree and you have chopped the bark of the tree into pieces like this, okay? Then you are boiling these pieces in water. So you have to boil them in water and boil till the solution is turning orange red in color. On cooling, the solution will become blackish. To that you add urea and ether, okay, and ultimately you are going to get you are going to precipitate a brownish tan powder, okay? A brownish tan powder will be precipitated in the end, which is further purified and sold commercially, okay? So basically the compound hematoxylin itself is having no capability to act as a dye. That is, it does not have any staining capability. Yes, you have heard it right, it does not have any staining capability. So you have to use a mordant to enhance the staining capability. So I hope you have seen my previous lecture wherein I have discussed in details what a mordant is. So I hope you remember what a mordant is, okay? That is also an important exam question, okay? So we will discuss in more what are the different kinds of mordants we are using with hematoxylin to improve the staining ability of hematoxylin. Now the oxidation product of hematoxylin. What is the oxidation product of hematoxylin? It is hematin. Okay, so remember, whatever hematoxylin powder that you are obtaining, this brownish tan powder, it first needs to be oxidized, okay? So basically the oxidation product of hematoxylin is called as hematin, which is a weak purple colored dye. So what is the method? How do you carry out oxidation of hematoxylin? Again, an important exam viva question. So there are two methods, okay? One is there is a natural method, another one is a chemical method. So what is the natural method? You keep the powder in sunlight and you expose it to the air, okay? So that facilitates the process of ripening or maturation. So this kind of oxidation, it is a very slow process and it takes almost around 3 months. So the advantage is that oxidation of hematoxylin, when carried out by the natural method, the shelf life or the life of the dye that is created is much longer, okay? Whereas in the chemical method, you have to treat the hematoxylin with either hydrogen peroxide H2O2, sodium iodate or mercuric oxide. So out of these three oxidizing agents, sodium iodate is the most commonly used oxidizing agent. Now over here, the advantage is that the conversion process, that is the oxidation of hematoxylin to hematin, is completely instant, okay? But the disadvantage is that the dye prepared has a shorter lifespan, okay? Now we will understand the concept of di-mordant complex. As I have already explained to every one of you that hematoxylin by itself is a very weak dye. It cannot act as a very dye. So you have to add a mordant to this particular dye so as to increase the staining capacity of hematoxylin. Okay, so we have seen that we have to first oxidize the hematoxylin powder into hematine. Now this hematine, if you see, it is a very weak anion meaning having negative charge. So it will not be able to combine with the nucleic acid in the nucleus. Why? Because they are also negatively charged. So negative, they are going to repel each other. But whenever we are adding a mordant to this particular hematine, mordant is nothing but a metallic salt. Okay, so whenever a mordant in the form of a metallic salt is added to the hematine, they are creating a highly basic or cationic positively charged dimetal complex. This metal that we are adding is acting as a mordant. We have already read about what mordant is. Okay, we are just revising it. Okay, so this metallic salt, okay, when it combines with a hematine, it is creating a cationic dimetal complex, which is a very strong basic dye, and therefore they are going to combine with the negatively charged nucleic acid. Okay, so what are the different kinds of mordants, or what are the different kinds of the metallic salts which are used? So we are having aluminium Al3+, iron Fe3+, molybdenum, tungsten, as well as we are having lead salt. So depending on the different types, depending on the different types of mordants used, we are having different types of hematoxylin as well. Okay, so this is the first part, that is the basics or the introduction to the H&E staining. So you have understood. I am just going to revise very fast. So you are obtaining the from the bark of the tree, you are obtaining the hematoxylin in the form of the dry powder that has to be oxidized basically you have to oxidize that particular thing into the hematine, as we have seen over here. So once it is converted into hematine, that is the oxidized product, it is then combining with the mordant, and only after this mordant is formed, they are forming a dimordant complex that they can combine and stain the nucleic acid that we are visualizing under the microscope. Now let us see what are the different types of hematoxylin which is available. We are having iron hematoxylin, we are having alum hematoxylin, tungsten hematoxylin, lead hematoxylin, and molybdenum hematoxylin. So whatever you are seeing, this iron, alum, tungsten, lead, molybdenum, these are all acting as a mordant. Okay, now we will discuss the process of bluing. Now remember, most of the regressive staining of hematoxylin needs bluing. So I hope you know what is the meaning of bluing. The bluing process just means that, for example, at the end of staining, maybe you get a reddish brown stain. Okay, so at the end of staining, usually you will get a reddish brown staining. To make it completely violet in color, okay, the color that we see under the microscope, we have to carry out the process of bluing to get a very crisp blue color. Okay, to get a very crisp blue color. So most of the regressive staining, so in the previous lecture I have told you what is progressive, what is regressive staining, so I am not going to repeat that over here. So most of the regressive staining of the hematoxylin needs the bluing. Okay, it needs bluing. So what is bluing? It is the removal of excess amount of hydrogen ion from the stain. This process is known as bluing. So here what is going to happen? Remember, the heme alum which is soluble, okay, which is soluble in this process of bluing will become insoluble. Remember that the bluing process gives a crisp blue color to the nuclei. In this process, remember the pH of the staining solution, or where, like for example, here we are carrying out the staining. So here we have kept some solution on top of this particular tissue. So basically the pH of this solution, okay, which is staining the tissue, it is made alkaline, approximately 8.5 pH. Therefore the tissue section treated with the alkaline reagent, remember whatever acidic reagents are there when we are staining, they get neutralized in the process. So what is the process of bluing? How are we carrying out this bluing process? So let me show you. So the most commonly used method in our country like India, the most commonly used method is by running the tap water for several minutes. So we have to run tap water for several minutes. So you have to just wash the particular slide in tap water. Okay, other methods are treating the section by Scott's tap water, which is coming at a pH of 8, and you keep it for 2 to 3 minutes. Then you can also treat it with the help of ammonium hydroxide 5%. You can keep it for 2 to 3 minutes, and you can treat the particular slide section with ammonia vapor for a few seconds. But out of these 4 methods, This is the one which is most commonly done, and this is what you do routinely in all the government medical colleges. Okay, always remember, because in the process of bluing excess amount of alkaline reagent or excess alkalinization is carried out. So excess bluing or excess exposure of the tissue section to the higher pH may cause the tissue section to shed out from the particular slide. Now we are going to discuss about the most important individual dyes. Okay, so let us read about the individual dyes. The first most important we will read is Harris alum hematoxylin. Now remember, this hematoxylin, it is a regressive stain and is widely used in exfoliative cytology as a nuclear stain. Okay, now Eosin is used as the counter stain to stain the cytoplasm. So basically the nuclear stain is your hematoxylin and the counter stain is your Eosin. Okay, the mordant that we use in this particular thing is ammonium or potassium alum. Now for regressive staining, we are we are putting the stain, that is the HNE stain, we are putting on the particular tissue section for 5 to 15 minutes, whereas for progressive staining we are just keeping for 5 to 30 seconds. So what are the different steps? Okay, what are the different steps of preparation of this special type, that is Harris alum hematoxylin? Now remember one thing, I have discussed two very important individual dyes. Now in your college 99% they must be using the Harris alum hematoxylin. Now depending upon whatever is used in your particular college, you please ask them that how you are preparing the hematoxylin, or are they producing any, or are they using any ready-made dyes. Okay, so you should have this information. Only then the examiner is going to be convinced that you have done the staining, because if you have really done the staining in your college, then only in that case only you will be able to say the steps. Okay, so just remember, how do you prepare this Harris hematoxylin? So 5 gram of hematoxylin dissolved in 50 ml of absolute alcohol. To that 100 gram alum in hot water, that is we take 1 liter of distilled water and to that we are adding 100 gram alum. Now this is solution 1, this is solution 2. Both the solution, they are mixed together and they are heated to boil. Slowly you have to add 2.5 gram of mercuric oxide and you should heat till the color become dark purple. Then you should rapidly cool the flask by dipping it in cold water. After that you can add 40 ml of glacial acetic acid, okay, to this cold solution. Okay, so always remember, it is not necessary for you to remember this step, okay, for your exam. Okay, but it is very important that you should remember this step if it is carried out in your institute in this manner, and these values are just standard values. It might vary from whatever you are using in your particular institute. Okay, so you have to have a note that addition of this glacial acetic acid, okay, it is an optional. Now why we are adding? Because it is giving a crisp blue color, but it also reduces the lifespan of the stain. Okay, so lifespan of the stain reduces in 2 to 3 months. Basically normally remember the lifespan of this particular stain, okay, this stain that we are using, that is the Harris alum hematoxylin. Okay, what is the lifespan of this? It is 2 to 3 months only. Okay, very, very important. Now remember, how does this lifespan of the stain deteriorates over a period of time? Because there is formation of precipitates and increased staining time. Okay, that is indicating that the stain material is deteriorating. So this is a very important viva question. Your examiner might just ask you that how do you know whether your HNE stain is proper or no? So if excess amount of precipitates are forming in your particular slide, or if the time which is required for staining the slide is increasing. So for example, initially you had to keep for 5 to 10 minutes in this range. Now you have to keep for 15 to 20 minutes. That means the lifespan of this particular hematoxylin is reducing and it is time to change that particular hematoxylin solution. So basically when these problems arise, okay, then what you can do in emergency situation, you have to precipitate, you have to always filter the precipitate, okay, before using the solution, and for the stain time you should increase the time of staining. Okay, so this is the number 1 form, that is the Harris hematoxylin, which is the most commonly available or used hematoxylin for routine HNE staining. We are using this. Okay. Apart from that, we are having the Mayer's hematoxylin. Okay, so remember the Mayer's hematoxylin, it is used as a nuclear counter stain. Okay, in situations where it is required to demonstrate cytoplasmic material such as enzyme histochemistry, okay, or while we are carrying out PAS staining, or in case of mucicarmine stain. So remember the Harris hematoxylin that we have seen over here, most commonly remember for routine H&E staining, for day-to-day routine H&E staining, this Harris alum hematoxylin is very nice, okay. But remember that Mayer's hematoxylin is also a nuclear counter stain, but it is used in situations where it is required to demonstrate cytoplasmic material such as for enzyme histochemistry, for PAS or for mucircarmine. What is the mordant that we are using over here? We are using potassium or ammonium alum. So very importantly, it is mainly used for progressive staining. You are keeping it for 5 to 10 minutes, and it is best suited in automated staining procedure. So it is best suited for automated staining procedure, okay. So what are the different types of what is the step? How do you prepare this Mayer's hematoxylin? So again, you don't have to remember the steps in detail, but these other points you have to remember, and you have to remember only those steps which are carried out in your particular institute. I am just telling you the standard procedure for making the Mayer's hematoxylin. So you take 1 gram of hematoxylin and you add 50 grams potassium alum and 0.2 gram of sodium iodate. All these three things you should keep, or you should mix in 1 liter of distilled water and gently heat the solution, and you should stir. Cool the solution in the room temperature. Then you add 50 grams of chloral hydrate and 1 gram of citric acid in solution. You should boil the mixture for 4 to 5 minutes, and you should cool the solution and you should filter, okay. So what is the basic difference between Harris hematoxylin and Mayer's hematoxylin? So the solvent used is absolute alcohol over here, whereas in Mayer's hematoxylin it is distilled water. The oxidant or the oxidation or the the oxidant which is used for oxidizing is mercuric oxide in Harris hematoxylin, and it is sodium iodide in Mayer's hematoxylin. Then the substance which is used to sharpen the stain or to give the crisp blue color is glacial acetic acid. Over here it is chloral hydrate. The stain type, it can be used both as a progressive and regressive stain, whereas Mayer's hematoxylin is mainly used only as a progressive stain. The third important type over here, we are having the Ehrlich hematoxylin. Remember, it is a strong stain for the nuclei, and they also stain mucin, bone, cartilage. Now the stain is oxidized by natural process, okay. And how do you do the natural oxidation? As I told you, you have to expose it to the air and sunlight for a period of 2 months, and once it matures, it can be used. And remember, such hematoxylin which is prepared by natural maturation or ripening or oxidation process have a much longer lifespan. The mordant used in the Ehrlich's hematoxylin is potassium alum, and the time to stain is around 20 to 30 minutes. Now there are different other kinds of hematoxylin too, like the Gill's hematoxylin and the Cole's hematoxylin. The Gill's hematoxylin, it is a good nuclear stain. The mordant used is aluminium sulfate, and it is mainly used as a regressive staining for 5 to 15 minutes. Then we have Cole's hematoxylin as well. It is again a good nuclear stain, and mainly it is mainly, if you see, the mordant used is potassium alum, and it is a regressive stain, and staining can be completed in 30 minutes of time, okay. The counter stain, if we see, the counter stain of the cytoplasm is done by Eosin. Okay, it is also staining the connective tissue and the matrix, the connective tissue matrix. Now it is staining rosy red to pink color. Now there are 3 types of Eosin. Now remember, in your exam, very commonly the examiner will ask you, most commonly in your college, you are going to find the Eosin Y. So there are 3 types: Eosin Y, B, and ethyl Eosin. So very commonly the examiners are very fond of asking the question, what does the Y stands for? It stands for yellowish. What does the B stands for? It stands for bluish. Now Eosin soluble. Now remember, Eosin is soluble in both water as well as alcohol. So it can be used in 2 manners. If you are mixing it with water, then aqueous Eosin is prepared, and 1% Eosin in distilled water is acting as a solution to be used. In alcohol, around 0.5% is made in 95% ethyl alcohol. Now washing Eosin stain with tap water helps in differentiation of the Eosin staining. So this is your counter staining by Eosin and the different types of Eosin. Next, we are going to see the steps of the routine hematoxylin and Eosin stain. So what are the things that we require? We require hematoxylin solution. We require different grades of alcohol. We require acid alcohol, which is prepared by by taking 1% HCl and 70% alcohol. Then 1% Eosin is required. This is the Eosin in aqueous media, and xylene. So let us see these steps. Remember, these will be asked in your exam. Every student who are giving the exam, you will be asked in details about the H&E staining. And remember, this hematoxylin Eosin staining, they can come as a long answer question in the exam as well. So pay a lot of attention. The step number 1 is to carry out deparaffinization. So you keep the section in xylene for 10 minutes each, and there should be 3 changes. So 3 times in xylene 10 minutes each. So there should be 3 changes. Okay. The step number 2 is the rehydration via use of graded alcohol. So you have to keep first in the absolute alcohol for 1 to 2 minutes, then 95% alcohol 1 to 2 minutes, then 80% alcohol 1 to 2 minutes, and 60% alcohol 1 to 2 minutes. After that, you rinse the particular slide with tap water. The step number 3 is the nuclear stain. So you have to use hematoxylin. Now remember one point, depending on which type you are using, if you are using Harris hematoxylin, then for example, most commonly, routinely, we are using this for routine H&E staining. So 5 to 15 minutes basically it is kept. But if you are using the Mayer's hematoxylin, some other timing will be there. If you are using for progressive staining, some other timing is there for progressive staining. So depending on the type of hematoxylin, you have to write down the time. But most importantly, in the most common routine H&E, we are using Harris hematoxylin, and the time duration is 5 to 15 minutes. So if nothing is mentioned, you have to write this only. The step number 4 is differentiation, which is mainly applicable to the regressive staining. So over here, you have to dip 1 to 2 dips has to be done in acid alcohol. So you have to give 1% HCl and 70% alcohol. Then you wash the particular slide. Check in the microscope to see if desired level of staining of the nucleus is achieved or no. The step number 5 is bluing. So you have to run it in tap water for 10 to 15 minutes. The step number 6 is the counter staining. You have to carry it with Eosin. So you have to keep 1% aqueous Eosin Y, you have to keep for 2 to 3 minutes. Okay, that is how the counter staining is done. The step number 7 is dehydration. You have to carry out with the graded alcohol. So you keep in 95% alcohol for 3 minutes, followed by absolute alcohol for 3 minutes, followed by again absolute alcohol for next 5 minutes. And last step is the clearing and mounting. So clearing, remember how you do, you carry it for 5 minutes each, in 2 jars. You have to keep it in xylene. How it is done, I will tell you. And mounting is done using DPX. What is DPX and how the clearing and what agent is used, I will tell you in details. Okay, so don't worry about that. Okay. So when you look at a well stained H&E section, it is looking somewhat like this. So you can see this is the nuclear stain over here. So let me use other pencils that you can appreciate over here. So this is the nucleus. Okay, this is the nucleus. Yes. So this nucleus is basically stained by your hematoxylin. Okay, hematoxylin, strong basic dye combining with the negatively charged nucleus. This is how you are getting the nuclear stain. So you can see it is deep violet to purplish color. Okay, as you can appreciate over here. Now you can see also, you can see this is the cytoplasm. Yes. These are what? These are all the cytoplasm. Okay, so these are all the cytoplasm. So what is the color of the cytoplasm? It is rosy red to pinkish in color. Okay, this is stained by the counter acidic stain, that is the Eosin. So this is how normally the staining should occur. Now we will discuss the troubleshooting, which is very important in your